Hello and welcome to my YouTube channel. So in this video we're going to talk about how to solve simultaneous equations using the matrix method. And here's our example over here. 4x plus 2y is equal to 8 and 5x plus 3y is equal to 11. So the first thing you want to do is to rewrite your equations into three parts to break it down that way. The first part we'll call it A. The second part we'll call it x. And then the third part, call this one B. And then in the A part, this is where your coefficients go, which are 4, 2, 5, and 3 in the same order. 2, 5, and 3. And the second part takes your variables x and y. And then the B part takes 8 and 11, what's on the right side of the equations. Okay, so it starts out this way. Ax is equal to b. Nothing has changed yet. And now what we're going to do first is multiply both sides of the equation by A inverse, by the inverse of A, like that. Now any matrix you multiply by its inverse will give you an identity matrix. So this becomes Ix is equal to, I'll just change the order here. It's just the same thing, multiplication is commutative. And then any matrix multiplied by an identity matrix is just that matrix itself. So we're only going to have x this side, then A inverse multiplied by B. This is the equation that we're going to work with. So our x is this part over here, is what we're going to start with. I'll just come over here, x, y. This is our x, according to this equation we just made over here to the right, is equal to, now finding our A inverse, find the inverse of A. Now to find the inverse of a 2 by 2 matrix, you say 1 over the determinant, then you multiply that by, you change some things inside. So let's do the determinant first. To find the determinant is you get the elements of the major diagonal, you multiply them, and then you find the difference with those that are in the minor diagonal. So we're going to have 1 over 4 times 3 is 12 minus 2 times 5 is 10. So 12 minus 10 is 2. And then we do that. This is our A inverse. The elements in the major diagonal switch positions. So the 4 is going to go down this side and the 3 is going to go up. So we're going to have 3 this side and 4 to the bottom right. And then those in the minor diagonal exchange signs. They change signs. If they're positive, they become negative. If they're negative, they become positive. So this becomes negative 5. Negative 5. And this comes negative 2. And then finally, we have a B, the far right. So 8 and 11. Nothing changes this side. Squash them in because of space. So we work this one out. We distribute the 1 over 2, and then we do the multiplication between these two matrices. So let's distribute this, see what we get at the bottom. 1 over 2 multiplied by 3 is 3 over 2. 1 over 2 multiplied by negative 2 is negative 1. 1 over 2 multiplied by negative 5 is negative 5 over 2. And then finally, 1 over 2 multiplied by 4 is just 2. This is what it becomes. And then we multiply the 2 using the row by column multiplication rule for matrices. And the final solution will correspond with the x and y that is on this side of the equation, like that. Because of space, we go to the bottom right, this side. So we say 3 over 2 by 8 plus that over that, plus that and that, just like that with the same at the bottom. See what we get. So this is going to be 3 over 2 multiplied by 8. This is going to be 3 by 8 is 24 over 2, which is 12. So we're going to have 12 plus negative 1 times 11, which is negative 11. Plus times minus is minus. So this is going to be minus 11. And then negative 5 over 2 multiplied by 8. This is going to be negative 40 over 2, which is negative 20. So we have negative 20 plus 2 times 11 is 22 plus 22, like that. So finally, 12 minus 11 is 1. And then negative 20 plus 22 is positive 2. So therefore, our x, the one at the top corresponds with a 1, so it's equal to 1, and a y at the bottom corresponds with a 2 at the bottom, and y is equal to 2. And that's how you do it. Thanks for stopping by, and see you in the next one.